You know what the most fun thing is with recording videos is when you spend 10 minutes talking and then you realize that your microphone wasn't working. So this is take number 2 of this video, and hopefully some of you out there appreciate that. But what we're going to be doing today is a demo of AI platform in Google Cloud. So I'll be following along with one of the code labs that are out there. Is a quick aside, if you want to play with AI platform or AutoML or TensorFlow or any of those, machine learning technologies that we've been talking about in class here, I'm going to kind of push you towards the quick labs side of explorations if you want to dig deeper. Um, the code labs don't seem to be as up to date currently as would be helpful for you all. Basically, there seems to be a lot of points during the code labs which are currently available. They might be being reworked, I'm not sure, but at like step 20 of 30, it just breaks because something under the hood has changed. So just be aware if you start trying to learn on your own because you want to do something different, maybe check the quick labs first because those are prioritized with being kept up to date. But enough initial talking here. What we're going to be doing today is we're going to be building a fraud detection model, and that's really going to be intended to show you how to use, TensorFlow and Keras, which um, Python libraries for deep learning and machine learning, basically what those guys are. We're going to be pulling a data set off of Kaggle, which is a website slash community for learning machine learning, learning data analytics. And honestly, if you are interested in this field, I would highly recommend you check out Kaggle. You can log in with your Google account, so you can get, I believe, credits in a similar fashion that you've gotten here. They have a lot of open Jupyter notebooks that you can play with to get up and running, lots of free data sets to prove out your algorithms and your models. Um, they even will run competitions to see who can get the best result on, say, a particular data set. So again, if you are somebody interested in machine learning, somebody interested in analytics of data, any kind of massaging of large data sets, this is a great place to check out. And it's kind of a nice community. The people that I have interacted with on this particular site, they all seem to be pretty nice and pretty welcoming, which depending on your um, community that you join, computer science or otherwise, it's not always the case. Sometimes it can be quite adverse, I guess, depending. But that's neither here nor there. Let's do a code lab here. So I have enabled the code labs, the AI platform API for notebooks. So we'll be creating a Jupyter notebook basically for this lab. And as always, I would recommend for you to create a brand new project for this and delete it when you are done, or at least disable it so that it doesn't suck down your resources. According to the code lab, it should only be $1 to do this lab, but if you leave things on, sometimes that doesn't really help here. So we're going to skip some of the boilerplate stuff here at the beginning. Basically, what we're doing is we're analyzing a large data set, and we are basically going to be explaining our data set, which, if you are new to machine learning, is a very important thing. You have to be able to explain what your model is doing. If you build a model in machine learning and you have no idea what the hell it's doing, it's a very bad situation to be in, right? Because you're releasing a thing that's making decisions for you and you don't know why it is making those decisions. That's a very bad place to be in. So be aware that as you go to the machine learning route and the AI route, if you don't know what's happening under the hood, that reflects very poorly on you, the developer of that model. So let's go ahead and go to, oh, I didn't enable the models aspect of AI platform. Brand new project for me here, so I haven't um, enabled everything yet. I thought I did that one, but we need models too. We also need compute engine. So let's get this up and running as well. Should be kind of starting up by itself. Yeah, oh, I already have this one, good. All right, so back to AI platforms. So models is enabled, we need a new notebook. So we're gonna pick TensorFlow 2.1 without GPUs. So TensorFlow, we'll go 2.1 even though 2.3 is available, just in case if something has changed and we don't want to get stuck. Leave the notebook name its default. I don't have any need to name it something specific because I'm deleting it after we are done. So this will take a moment to spin up, and once we are at that point, we'll create a Python 3 notebook, and we will get on with our lab. Okay, and we're back. That took probably about 5 to 10 minutes. I had some other stuff going on off screen, but Jupyter Lab is now up and running for us, so we're going to pop that open, and we're going to set up a Python 3 notebook. And what we're going to be doing here is dropping these imports in, and what you see is that we're going to be importing a bunch of Python libraries. So we need itertools, NumPy, Pandas, TensorFlow, JSON, Matplotlib, Explainable, AI, STK. Really, these are all kind of important, but Pandas is going to handle our data frames. TensorFlow is our machine learning library. Matplotlib is probably going to be our plotting engine. And sklearn, explainable AI, these are going to go into our machine learning aspects. So Python 3 notebook. Let's import these in. Oops, just copy and paste the correct thing. So this is code, important. I'm going to name this notebook as well so that we know what this is. Let's call it AIM 680 demo. Good enough. So we have some packages we're importing here. Click run. See it working. Again, little filled in dot. Shouldn't take that long, but maybe it needs to actually pull down the explainable AI. All right, if there was a problem, you would see an error spit out right underneath it. So we are going to use, again, a Kaggle model. Now, this is synthetically generated, meaning that this is faked data, but it's based on real-world ideas. As explained here, you probably are going to have a hard time finding real-world credit transactions, so we don't necessarily want to do that. So let's go ahead and run a gsutil command right inside our Jupyter notebook, which is a new thing for us. So let's run that. And we should see it pop up here. So we see it's going, and we have a 300 megabyte file about. Operation completed, CSV pops up. All right, so that is good. And again, if you're not familiar with Jupyter Notebooks, they're awesome, awesome, awesome ways of running Python code and writing in, kind of like a lab report or a document type of thing along the way. So I could be adding in markdown fields in here that are explaining all the different steps, which, if you're sharing these or you're saving it for future reuse, it is awesome. Awesome for that. So let's read the data frame into pandas, and then we're going to print out the head. And we are dropping the type column as well. Let's go ahead and do that. It's going to run for a bit, depending on how long it takes pandas to parse out the CSV file. And there we go. So here we have our exact imported fields into our data frame. And you could download this data file, and let's take a look at it. Let's look at it with CSV table. I was thinking about downloading it and opening it in Excel, but let's just use the tools that are baked into our environment here. All right, so this shouldn't take too long, I wouldn't think. Maybe it will. Okay, there we go. So here we have just tabular data. Consider it similar to a common transactions database. So here you have old balance, new balance. Does this flagged as fraud? What is our original balance? What's the name of the transaction? What's the amount? What type is it? Is it a payment, transfer, cash out, that kind of stuff. So typical things you would see with transactions when we're dropping the type table, because for this particular data set wasn't important. And again, when you look at this table here, we see that that was dropped. Again, more particular to how we're massaging our data set here. So one of the things with this data set is it is considered imbalanced. 99.9%, as you see right there, are non-fraudulent, meaning that when we train, our model is going to take that into account. So we want to balance it. So what we're going to do now is to balance this thing is we're going to split up our data set into two separate data frames. So one where we have the data is fraudulent and not fraudulent. Runs pretty quickly, and we can print out fraud. I think it's fraud.head, since we don't want to see the whole thing. And then not fraud, so this is not in the lab, but just kind of using common Python commands here. So what we should see is fraud is 1, is fraud is 0 down here. So again, we have split up our data set. So now what we're going to do is we're going to sample them, and we are going to shuffle them together. And again, I'm going to leave it to you mainly to kind of read through why we're doing this in terms of analytical purposes, because otherwise I'm just going to be repeating the text that you see here. But mainly we are kind of recombining our data sets, and we are going to have a random sampling of fraudulent and non-fraudulent. So data set massaged, now we're going to split it into a training and a test set. If you recall from our example before, we are training our model on the threshold depends on what you particularly want. Here we're using 80%. So 80% of the model is training, 20% is testing. And the goal is that we have trained our model appropriately. Anything that we use in our test set will be predicted correctly. And you can use that to really verify your model in that regards. So we have our training set and our test set. We have labels as well. Now, what we have to do is start doing actual machine learning. This has all been data massaging. So first things first, let's normalize our data so that if something is kind of out of scope or out of range, it is normalized into the correct range. And we're going to be using a scalar here, and we're going to be using some NumPy functions for trimming down our set a little bit, both test and training. Runs pretty quickly. We can take a look at our training sets. Don't have to print because print is implied here. We see an array of a bunch of numbers, and that is going to be what we feed into our model. So now, one of the things that Keras needs is some weights. So we'll be using these in our model as well. And again, you can see how these libraries that we're using are really taking the brunt of the mathematical effort for us. We don't have to do a lot of figuring for weights and inputs and things like that. Basically, how much weight does each example give you, I guess, to maybe explain that better. Now, we are going to use the Keras sequential model to build the model for us. And we could use a different approach as well if we want. You don't necessarily need to use Keras.sequential. There are other options if you would prefer a different model. But what we're going to be doing here is defining a bunch of metrics that are going to be fed into our model. We're going to build our model using the correct API calls. And again, it could be different if it's not sequential. We're going to define our activation function. Again, very specific things to our model here. And then what we're going to get is a model out of it. And again, these are just functions that we're defining here. We're not actually calling it yet. We have to call make model for this to happen. All right, so these should look familiar as well. Epochs and batch size. So this is going to be how long we allow our model to train. And if we hit a certain threshold, we're going to allow it to bail out early. So we're going to go ahead and set that. And now we're going to make the model based on all these parameters, based on our model functions, and then we're going to summarize it. So model is created. We see it's a dense model. We have some dropout, and everything that we need to know about our model is in here. So lastly, we have to actually train it. So we created the model, we set its parameters up here, set its weights, created our training and test set, and now it's time to actually let the model run. And depending on how busy the server is and how complicated your data set is, this will take a varying amount of time. So we see epoch 1 out of 100. Depending on if we converge early, it will either bail out or we will take a while. So I will be back in a few moments.